I'm just wondering if Morris is there. Morris, are you there? Huh? I'm sorry to bother you, right? But I just want to understand. Do you know what an intake is? What is? Exactly. My own COO doesn't know what an intake is. Again, you know, and that's why it's so important, guys, that you have to have professionals that understand what they're doing, not these high flyer, very expensive executives of mine. Do you know what an intake is? Okay. Welcome back to my YouTube channel, guys, and today we're gonna go and speak to Christine, the PM for the Ministry of Water project, which is obviously a very, very important project for the country as well as for Nexus Green. So I can see her signing in today. So let's go grab her. Hi, Christine. How are you?
Oh, I'm okay. Hello, Ricky.
Yeah,
Morning.
welcome to my YouTube channel.
Oh, thank you.
So we're going to ask you a few questions. So I'm going to follow you now to your office, and then we're going to talk about intakes.
Intakes are structures that we put in place to be able to abstract water from these different sources, either rivers, mainly surface water sources, rivers, lakes, swamps, and then channel that into a sump somewhere where we can now place our pump and pump this water to where it's going to be utilized, to our irrigation schemes.
Am I going to see people like in scuba outfits going into the depths of Lake Victoria?
Well, for some, like the Lake Choga intakes, thermolators, we might get to see some of those. But for the ones we are visiting tomorrow, it's plain river water intakes. We're just going to have some channels going into sumps, but it's also quite interesting.
Can I ask you, like, is it a one-day job? Is it a few days job? Like, just feed us through the process. What goes on from, is it a design and then implementation? How does it work?
Yeah. So, I mean, as part of the design, our design team will go to the field and identify which is the best water source to, feed into the specific water need we're addressing at that particular time. So, especially if you're looking at irrigation schemes, this is where we have surface water intakes. Then we'll identify either river, and then they'll have to pick the best abstraction point. So the one where we don't get in a lot of silt, for example, so the lowest silt load, otherwise that would damage our pumps.
So to design it in days, how long does that take?
I mean, if someone is in the field, they pick data and then they input this, maybe 5 days.
5 days, and then to actually install?
Install, we need maybe 2 weeks.
2 weeks to
depending
install.
on how complex, yeah.
Okay,
2 weeks, yeah.
And how many intakes are we doing for this project?
I mean, we have 252 irrigation sites, so that's how many intakes we have to do.
That's a lot of intakes. Okay. Well, Christine, I think I kind of know what intake is. I'm going to ask some of your colleagues if they know what intakes are. All right, let's go around and see if anyone else knows what intakes are. George, I know you deal with the numbers for this project, but, it's important that we all understand what's going on, especially with this project. So what is an intake?
An intake is a structure we build up to extract water from a surface water source.
Oh, wow, okay. So you're now an engineer?
Somehow. I'm an
Okay,
engineer.
good. Okay. And it's very important to have intakes?
Yeah, it is very important because most of our pumps are submersible.
Yeah.
So to keep them away from surface water sources, you need to dip them into something. So that's why you create an intake, to have an allowance where you're going to submerge your pumps.
Okay. And George, even though he looks 21, he's about 45, so he's got a lot of pedigree and history about what intakes are. The man of a lot of wisdom here. So what's an intake?
An intake is a structure that's built to draw water from a surface water source.
He's actually reading from Google right now. I'm looking. Okay.
So we need them on our irrigation sites mostly. Our water supply sites use a borehole, but the irrigation sites draw water from surface water sources like swamps, lakes, rivers, and so on. So we need a structure that helps us channel the water in a sort of filtered state to the pump, where we can then raise it to the reservoir.
So if you don't have an intake, essentially, could the pump disappear with the current?
Yeah. I mean, you could. Yeah, certainly in rivers. The intake also needs to protect the pump as well as just hold it in place.
Yeah, because it sounds like a thing that is definitely needed.
Yeah.
All right, thanks, Chris. Okay, I didn't know what Chris actually did here, so now I do. He understands how to read Google. All right, let's go in and see. So, Obviously, intakes, you appreciate it's got a lot of fundamentals. One, to keep the pump secure. Two, to keep the integrity of the current of wherever they're pulling the water from.
The intake is basically the structure to contain a pump so that we're able to pump out water to where I want it. So its main purpose is to make sure that it gathers water a bit clean for the pump to suck, and then also contains it for security reasons so that they don't steal it. And also nothing runs over the pump. So it keeps the pump safe and also with enough water to be pumped so that we are able to get enough water that we need. So we compute and then get how much we are retaining and we are able to pump out the water to where I want it, the reservoir.
Why do you need to put an intake in?
To basically regulate the amount of water that we are abstracting from a surface water source.
Yeah. And also, is it a case of like we don't want to lose the pump? Can the actual pump go like with the current if it's not part of an intake?
There's a possibility, a huge possibility.
And these pumps, they look expensive.
Quite expensive.
They look expensive and they look big, and it looks like I would probably be quite upset if you lost one of these.
This is a PVC pipe, a 4-inch pipe.
4 inches,
Yes, and it is used to convey water from the surface water source to a sump. Yeah, the intake is formed by part of the water body and the sump. So this pump is what is put inside the sump. To get the water.
Mercy, you have made it a lot more easier to understand. I'm not going to ask George ever again. He should stick to his day job. So guys, tomorrow we're going to be in the field and you're going to actually see an intake being installed. It's really important for you guys to see the complexities of these installations, because I think what we do is we take it for granted in terms of just seeing a finished product. So it's really important for my viewers, you guys out there, to see exactly how it's all done. So stay tuned and I'll see you in the field. Peace.
Today we came to visit the construction, to supervise construction for 2 sites, specifically the intakes.
It's actually the one which was shifted from this one here, because it was supposed to be the other side. So they shifted it to this other side.
We put it to the other side. Hydraulically it may not have much of an effect, but still how about functionally? We are overseeing this project that is spread all over the country. But in particular, me, I'm in charge of Central and Southwestern. We can know how much volume we have in here that is going to be flowing, according to the cross-section, that is going to be flowing into the sump.
Operation of the irrigation system is always based on the water source. Like when you have the water source, we are sure that we are going to get the water, we are going to pump the water, and the water source should have water flowing in consistently.
We get water from natural water bodies like lakes, rivers, streams, and swamps. And such water bodies are prone to foreign bodies, which foreign bodies can come and actually destroy the pump. So we ensure that in our design and during construction, we filter out those debris and foreign objects so that we have minimal exposure of our pump to anything that could damage it. We also ensure that the water quality is right, because once the water quality is wrong, then we are going to have erosion of our pipes and the entire system, and even it will affect the crops.
We are going to do as-built drawings, so if this was not captured, we are still going to need that information. So we might as well get him now, and we get that just to verify, and we see if we need to adjust anything already. I think we can.
Yeah, we need to prove that this side we have enough land to irrigate. We need to prove that.
Here in Central Region, we have a community liaison officer who ensures that all stakeholder engagements are taken, steps are taken, engagements are done with the district, engagements are done with the farmers, and all the parties are brought together, and there is an understanding by the beneficiary of what the project is supposed to deliver to them, and where they have queries and questions, they are answered, and that is how we ensure that all beneficiaries receive what they're supposed to get.
We created a channel from which we abstract water, and we are going to put it in a sump. You can see we have a silt trap in there to make sure that we don't get silt into our pumps to spoil them, so we'll get protection from that.
This is a project that is very, very high on quality, and so we don't compromise even with our subcontractors when it comes to quality. All the materials that we supply have to be as per the specifications in our contract with the Ministry of Water and Environment, and so that is something that we are very keen on, and we always ensure that it is adhered to by our subcontractors.
From the design period, our design stage, we have a whole environmental department that actually looks into the impacts of the entire irrigation scheme on the ecosystem. And therefore measures are put in place. For example, if we realize that with this kind of extraction, this place is going to run out of water, you wouldn't want that to happen to the ecosystem. And therefore, when we find something like this, the whole scheme will probably be put off. And therefore, whenever we reach a stage of saying this scheme will work here, it is because the measures, the studies have been done, and has been concluded that the effect on the environment are minimal, or they outweigh the benefits. And therefore, the scheme will be given a green light to proceed. Otherwise, it will not take place.
Intake consists of a channel which is well protected and fenced from any external attacks or anything, and then that water goes to the sump well where we pump it to the reservoir. So basically from the pump house, water runs in the pipes, and those pipes, of course, they are not open and they are buried underground. So they are protected from all these other external and movements, outside movements. Yes, so from the reservoir is when water flows to the main lines, in the sub-main, then to the irrigations. Yes, so basically in that process we don't have any external attacks or anything that can bring blockage, yes, in the pipes.
I would say the biggest technological advancement that we have on this project is the use of solar energy, which is basically enhancing what God has already given us freely, the sunshine, and seeing how we can utilize that energy to provide water and make people's lives better.
These irrigation schemes are designed particularly to take care of the effects of the dry season. We may not need irrigation schemes in a rainy season when we have too much rain. No, they come into effect, or their use is at the peak during the dry season, and therefore, when they are designed for the worst case scenario, droughts, to make sure that the water is there to serve the purpose, because we want continuous production, be it a dry season or a wet season. And therefore, they are designed actually to perform in the dry season.
We've also seen that this area people are doing a lot of coffee, which is also good, also contributing to the other side of the GTP, specifically cash crops, which are, crops which are really contributing to GDP. So we are happy that also the project is contributing to these other aspects. We are working with a contractor here called Leo Contraco, and I think he's doing a good job. He's also been quite fast, and looking at his quality, even the OE has recommended that we give him some more work, because he's doing a good job. So we are happy with this, and we've also learned a few also still teething problems with the construction of the intakes, which lessons we are going now to pick up and take to the other sites and see how to improve and also work better.
This is among many schemes that are in the country, like one of a kind, which is spread all over. For sustenance, for economic transformation, this is part of the program. And therefore, when these designs are being made, sustainability is key in the design, there is a whole team that will be handling the operation and maintenance long after the construction is done, and that will ensure sustainability.
Farmers have been crying during the dry seasons. They don't have water, the crops are drying, and then there's no good yield. And now, since this project has come up, the irrigation projects, and Nexus Green being a solar company that is providing solar, people are able to get water, people are able to irrigate, and at no cost. There is no cost of maybe electricity to run the system. We use solar, which is natural. So this is all ensuring that we maintain the green environment.
This is what Uganda has been waiting for, or what has needed for a long time. Irrigation schemes where we are going, considering climate change, basically the changing of times. I believe that this is what we need to ensure, one, food security, and two, economic transformation. And on this, I therefore recommend the government.
Nexus Green, everything solar is the way to go.
What a great video. So now you saw intakes. I hope you appreciate what intakes are now. I hope you enjoyed this video again, and I look forward to our next journey. So remember, share, like and subscribe, and I'll see you guys later. God bless.